Hi everyone, I'm Chong Wu. I'm also from LikeCoin Foundation, like Alu. And today's topic, I actually forgot what I submitted for the actual topic. But I know the keyword is Dapp, and I know the intention is to write, show you how to write a Dapp. So let's write a Dapp. First, what is a Dapp? Dapp is decentralized application. So now you know what is Dapp. Yeah. What is not a Dapp, or what is a traditional application? For traditional application, you have a server which runs your code and access your database, and then the user maybe is using a browser. Your application is a web application, so the browser connects to the server and access the result of running the code. This is fairly simple, but nowadays it has a few problems. First, if you are a developer, an application writer, you need to find a server to host your application. Maybe you choose AWS or Google Cloud or some cheap web hosting, or you host your server alone by yourself. But still you need to deal with the problem that your server may not be accessible by the users sometimes. Maybe Google Cloud just shut down like Google Reader, I don't know. Maybe you run your server yourself, but your ISP is not that reliable. That's something that you need to worry about. And as a user, if you are a user, you will worry about another thing. That is, how do I know that the application run as the one who hosts the server claim? Maybe the one who hosts the server just manipulated arbitrarily, and suddenly I found that my data lost or being corrupted. With a decentralized application, we replace the server with the blockchain. The application and the database are hosted on the blockchain, which is a network that's interconnected peer-to-peer, and your code, the application's code and database will be stored and run on different computers among the whole network. Therefore, even if any node fails on the network, your code still could be accessible and run on other nodes. And as a user, since the code is already distributed onto the network, the application writer cannot manipulate it, and the user can verify that the application is actually running like what he claims. Let's talk about an example. Say we are now in a university class. This room looks like a classroom. And the lecturer wants to have some democracy in the class. So he wants to have a voting system, and the students as participants can vote for, say, homework, class schedules. The design of the system will be like this. Is it too small to look? Okay, I just talk. The teacher will be the host, and only the teacher has the right to create a new proposal. And the proposal will have some simple string as a description. The students are the participants. Therefore, we don't deal with airdrop period. Just assume that the list of the students are predefined. They will not be removed nor added. And each of the students can vote for each proposal. Maybe once and only once. The voting system will not allow double voting for the same proposal. The traditional approach is first, the teacher finds a server, hosts his application. The application will define some API, maybe RESTful API, for creating, querying, and voting the proposals. And the teacher's account or identity will be hard-coded inside the application, so the application can verify that only the teacher can create proposals. And the student's account or the list of student accounts are also hard-coded in the database, so the application can verify that only the students can vote the proposals. And the server will ensure that every student can only vote for once for each proposal. After writing the server, the teacher just needs to write a web front end for the students to access the server. This is the traditional approach, and what would be the DF approach? Actually, quite similar. We just replace the server with something we call smart contract. By the way, we were using the Ethereum blockchain, so smart contract is just program in the blockchain terminology. And then the identity are not accounts, but some Ethereum addresses, which are the identities in the Ethereum network. And that's all we replace that, and we still need a web front end, which just keep it. Before introducing the app, we need you to know some concepts. First is a private key. What is a private key? Private key acts like the password for an account, but it's for blockchain, or for more precisely for cryptography. Yeah. A private key is some secrets that the user store and not revealing to others, so that the user can use the private key by some magical mathematical operation. He can prove his identity. And the Ethereum address is the fingerprint or the hash of the private key, so it can be used as the user's identifier. Note that we can derive the Ethereum address from the private key, but we cannot derive the private key from the Ethereum address, so it's safe. And smart contract, as I said, is just code that execute on the blockchain plus some storage that's the base, so it's just programming blockchain works. So how does Ethereum DF interact with your code? How does it work? First, user needs to install an extension in their browser called MetaMask. MetaMask will manage the interaction between the program and the blockchain. It will also manage the user's account, therefore the private key could be stored securely without being leaked. And the program will interact with MetaMask. And MetaMask will see that does this request need user's approval? Say, is it sending money? If so, it will prompt a pop-up for the user to confirm. After that, the request will be sent to blockchain, execute on blockchain calling the smart contract. And then once execution done, which takes a while, the data will be sent back to MetaMask and then sent back to the code. Very simple, right? So let's see the demo. The application will consist of two parts. One is the program, the code on the server or the blockchain, which is a smart contract, and another will be a web front end. I will develop the smart contract. I developed the smart contract using an IDE called Reinvent, which is a web application runs on the browser, or it also interacts with the Ethereum blockchain through MetaMask. And this tool is an IDE for developing the smart contract, and it can help me to develop, deploy, and test the smart contract. When developing smart contract for Ethereum, we use a language called Solidity, which is a weird language, really weird. It looks like JavaScript, or looks like Java, I don't know. But it is statically typed. That is, the variable has types. And it also has some access control, so I don't know if it is JavaScript or Java. It's some mixture of them. The application is very simple, less than 50 lines. In the application, we define a few variables for who is the host, who are the participants, and a record for the votes, so we can prevent double voting. We also define the data structure for a proposal, which has a string as description. The vote result will be a few count for agree and a few count for disagree. And the proposal list will be stored in the array and also the length of the array. There are three functions in this proposal, in this smart contract, of course. The first one will be the constructor, which acts, well, like a constructor. Okay. This constructor will be called when deploying the contract, and it takes a participant list, which is an array of addresses. It sets the one who sent this message, which is the one who called this function, as a host, and then mark everyone in the list as participants. The two functions, one is for creating a proposal, and one is for voting. When creating the proposal, it takes a description, check that the one who called the function is really the host, create a proposal, fill in the fields, put the proposal in the array, and then increment the proposal count, which is very simple. If you develop a traditional app, the logic will look like that, just in another language which is not that weird. And then when you vote for a proposal. This will be the index of the proposal in the array, and also the vote value. It validates that the proposal is valid. The caller is really a participant, and he does not vote for this proposal. And then it marks that this guy has already voted for this proposal, and then increment the count according to value. Now I have the smart contract. I can compile it. I take auto compile, so the compilation is already done. And then I can deploy it onto the Ethereum network. Okay. But first, I need a participant list, which is I have a few identities in MetaMask. One is the teacher, and 3 for the students. So I need to copy their identities. MetaMask will prompt that are you really willing to send this transaction, because it will cost some money for you. And I submit it. Then it will show that your transaction could be queried here, is submitted in the blockchain. And this is either scan, one of the application on Ethereum. And it is used as a block explorer, which is used to investigate the blockchain. And this transaction represents the action of deploying the contract on the network, and it takes a while. Okay, either scan is a little bit slow, but the idea tells me that it's already deployed. And then we now deployed the contract. You can interact with, call the function and interact with it. But I'm not going to use the IDE to interact with it because I need to web front end, right? For the web front end, what happened? Okay. The web front end to interact with the contract, the web front end needs to know 2 things. The first one is the address of the contract. In traditional server application, you need to know the URL of the application. It's just similar to that. And then I can copy the deployed contract address here and paste it here. Another one is the API. Anyone knows what API stands for? You know, API stands for Application Program Interface. API is a similar concept called Application Binary Interface, which defines the binary, in binary level, the interface of the program. Which function does this application have? What are the attributes of the functions? How many parameters they take? and we know that we need that for the smart contract. And this is one of the compiler output, the metadata, the EBI. And we can paste it here in my application, which is the JSON array. Now we have all these infos, we can write our web front end. But first I need to run the bundler for me. Sorry, from Dapp. I need to start the bundler so I can access, compile and run my application. For the application, most of it is just like a normal web app. And the only difference part is the part interacting with the server. Now we'll interact with the blockchain of the server. So I will explain that later, but we do that by a library called Web3. So let's take a look at the application. Yes. The application shows that I'm under this address and I'm a teacher. And then it shows no proposal because, well, I haven't made one. So now I can submit a proposal as a teacher. The content could be okay. Okay. There are some problems in the screen, so everything can see it, right? Okay, I can submit a proposal, maybe. Handsome. Yeah. And then I can submit this onto the blockchain. Once again, MetaMask prompt to me that I use asking for permission. Submit this. And then the console log shows that I'm creating a new proposal with this description. And I can check the transaction here. And one of the disadvantages of using a blockchain is that it's quite slow. Yeah. Okay. The processing is done. Therefore, we can now see that the app has updated its status and queries something from the blockchain. The proposal ID is 0. The description is the teacher is handsome, and then now the full result is 0 agree and 0 disagree. There are two buttons, one for agree, one for disagree, but I can't click them because the teacher is not one of the participants, which is there. So now I can switch to a user account, maybe Alice, and then it will automatically refresh, and now I can go for agree and disagree. Alice may want to go for agree by because he wants to get high marks in the exam, I don't know. And the vote is submitted onto the blockchain. It's voting for proposal 0 with value true. By the way, now you know that why we need a sidechain. Because this is on the testnet. The testnet is much faster than the mainnet. If you are on the mainnet, then I can have another talk for the result. So now the result has updated, 1 agree and 0 disagree. So how do I do this? How is the front-end code doing and accessing the data? Which is quite simple. We can take a look into the front-end code. First, we use a library called Web3 to interact with the blockchain. After installing MetaMask will inject something called window.web3, an object into every tab, into every tab. Therefore, I will initialize my own Web3 instance using that Web3 object. And then I have the way to connect my application to Web3. Also, I initiate a contract object to interact with the contract. And then I tell Web3 the API of the contract and also the address of the contract. Then I can interact with my contract using this object. And for the methods, we have 3 methods, one for querying the result, and 2 for voting and creating proposals. The first one is the refresh function, which clear all the data and then fetch it from the blockchain again. First, the program will get the address of the user, which is done by Web3, very simple. And then the API to get the contract data, say the number of proposals, the proposals data, and its participant data and the host data are all done within one call. They just interact with the both object calling the function with that name respectively, and then a dot call method which represent the call, and then the library will do that thing for us. If you think about it, when you are developing a server application, it's actually more complicated because this code will be more or less the same. You still need to get a proposal count by a RESTful API call, but then you still need another function to wrap your call into a RESTful API call. But in Web3, the Web3 done the jobs for us because it has exactly what the function can do by the contract API. Therefore, it is actually more simple than traditional application. And then for the vote and creating proposal, which are something that change the state of the contract, it's actually even easier than queuing the stage because you only need one line to call the function, put in the parameter, something that you need to look for the document, I don't know, and then it's done. Therefore, developing a Dapp is actually quite easy nowadays. You may ask, if you are concentrated enough, you will notice that there is a bug in this program. Yeah. The bug is that, say, Bob now want to vote for disagree, which is what a normal person will do. He vote for disagree. He hates the teacher so much that he wants to vote twice. And the button is not disabled when waiting for processing. So maybe he can vote for twice. As you can see, 2 vote for proposal 0 with value false. Got some error message. Why? The first one is voting done, and then the second one got some error message called transaction run of get people, blah blah blah, I don't know. And the result is consistent. Only one disagree is accepted. If you look at the transactions respectively, first one, the first transaction has succeeded. And the vote is created. And the second transaction is processed and failed. Because we explicitly ensure that everyone can only vote for once for each proposal. Therefore, the blockchain will enforce this checking. No matter if you are a teacher, you are the one who deploy the contract, or whatever, this application will ensure that on the blockchain will ensure that the result is running exactly what the application programs. So the demo is done. So for the code and reference, for the code you can get in from the LikeCoin Github repo. And if you are interested in developing a Dapp, you will need the Web3 library, and also the Solidity language, which are all well documented. And you can access the document or read the doc.io. Okay, this is the end of the debate edition. I don't know why it doesn't get this the end. Okay, this is the end. Any question? Any yes?
Can you give an example how do you actually do testing or debugging?
Testing or debugging. This is actually hard. Really hard. Very, very hard. Because we program how do we debug the program? We use console log, printf, something like that. But in a smart contract, you don't have printf. The blockchain will not show you an exception. It will show that only. It will only give you something like this, which is completely useless. It only tells you that you failed. Normally, we can use the debugger and then run the. Actually, the remix ID allows you to run the application locally in the JavaScript VM. Therefore, you can not actually deploy the contract on the real blockchain, but deploy it on a local blockchain. And then you can see there is a debugger here. Therefore, you can have breakpoints and try to debug the program. But it's always crash and fail. So sometimes we use something called reinvent, which is a mechanism for the Ethereum blockchain to tell you that something happened, and you can define your custom event, and then you can use that like how you use printf, which is not a recommended way, but sometimes it's the only way. Any other question? Yes?
So we have the testnet is take like 10 seconds or 20 seconds for a boat.
Yes.
So well, you mentioned that it's much more slower than on the mainnet. So how much slower? Like
well,
1 minute or even longer.
And there is in real life, people won't do these things, won't do the computing for you freely, therefore you need to pay transaction fee, right? And then we have a website called the gas station. Gas is just another unit for transaction fee. And then it fluctuates a lot for the mainnet. As you can see, the gas fee is 2 gigaway, which is a unit. 2 gigaway for less than 30-minute processing. And if you want a faster processing, it could be 18 gigaway, which is nearly 10 times of this one. And it also depends on how complicated is your contract. Say you are running an infinite loop, then your transaction will take much more than just simple manipulating the state. Normally it takes I think if you are using 1 gigaway, then it takes about a few cents in US dollar, a few cents in Hong Kong dollar for lightweight operations, for normal operations, I would say.
So it will be less than 30 seconds. Right.
As I said, the time it takes fluctuates because if you're paying the same gas price, then sometimes maybe now I pay for 10 gigaway and the network will process it within 2 minutes. But sometimes maybe there is an ICO, therefore the network is really crowded, therefore it takes much longer to process, or you need a much higher gas price in order to make your transaction fast enough. Normally it will take 2 minutes, within 2 minutes. Any other question? Okay, thank you very much.